everyone, welcome to In Depth. My name is Aditi Girotra. If 2019 was all about the moon for Indian Space Agency ISRO, year 2020 could well be about the sun. In his Mann Ki Baat address on Sunday, Prime Minister Narendra Modi spoke about the ISRO's plans to launch its first sun mission, Aditya L1. This ambitious plan of the Indian Space Research Organization will not only put India in a very elite league, but also at the very frontier of cutting-edge research. With Aditya L1, ISRO will take a huge step forward in the study of solar corona. The solar corona is the outermost part of the sun's atmosphere. It is usually hidden by the bright light of the sun's surface. The 400-kilogram class Aditya L1 will carry 6 scientific payloads that will be inserted in a halo orbit around the Lagrangian point 1 or L1. Incidentally, L1 is 1.5 million kilometers from the Earth. Our focus today will be all about the impending sun mission of ISRO. We will also look at some of the prominent missions undertaken so far to unravel the mysteries of solar space and also the journey of ISRO itself. In the year 2020, Indian Space Research Organization is looking to cross new frontiers. After a successful moon mission in 2019, the space organization is now eyeing to decode the sun. The ISRO is planning to launch an ambitious solar mission, Aditya L1, in the coming year to study the mysteries of the sun. Here are the details. Just months after the successful launch of the ambitious moon mission Chandrayaan-2, India has set its sights on the sun. Indian Space Research Organization will launch its maiden solar mission Aditya L1 to unravel the mysteries of the celestial body that sustains all life on Earth. Speaking about it in his last Mann Ki Baat program from 2019. For 2019, the Prime Minister said that India is quite advanced in the field of astronomy and ISRO has taken path-breaking initiatives.
सूर्य के बारे में रिसर्च करने के लिए इसरो आदित्य के नाम से एक दूसरा सैटेलाइट भी लॉन्च करने वाला है। खगोल विज्ञान को लेकर चाहे हमारा प्राचीन ज्ञान हो या आधुनिक उपलब्धियां, हमें इन्हें अवश्य समझना चाहिए और उन पर गर्व करना चाहिए। आज हमारे युवा वैज्ञानिकों में न केवल अपने वैज्ञानिक इतिहास को जानने की ललक दिखाई पड़ती है, बल्कि वे एस्ट्रोनॉमी के भविष्य को लेकर भी एक दृढ़ इच्छा शक्ति रखते हैं।
The launch is scheduled for mid next year on board Polar Satellite Launch Vehicle. Conceptualized in January 2008, Aditya L1 mission was originally named Aditya 1. It was initially conceived as a 400-kilo class satellite carrying one payload, a coronagraph. However, the enhanced Aditya L1 will be carrying 6 payloads. The satellite will be inserted in a halo orbit around the Lagrangian point 1 or L1, that is roughly 1.5 million kilometers away from the Earth. Being placed in L1 position gives the satellite the major advantage of continuously viewing the sun without any eclipses. Originally, the main objective of the Aditya 1 mission was to study the solar corona. However, the Aditya L1 mission now plans to carry out experiments to study other layers of the sun's atmosphere as well. Other than corona, it will also study sun's chromosphere, photosphere, the particle flux emanating from the sun and reaching the L1 orbit.
New name meaning, this name was given somewhere around 2019. This mission was started, this thinking started from 2017. Initially, they thought of a very small satellite, only a 400 kilogram weight satellite to be put on Earth's orbit to study sun. But then when people looked at it, they found that there are very interesting questions of sun. So then the ISRO and the Government of India decided that we'll go for a full-scale study of sun, one full-scale space laboratory.
The photosphere is the innermost layer of the sun's atmosphere, about 500 kilometers thick. The photosphere is the source of light and solar flares. The chromosphere is the next layer that emits a reddish glow that can only be seen during a total solar eclipse. The corona is the outermost layer, an aura of plasma that envelops the sun and is visible to the naked eye during a total solar eclipse. It appears as white streamers or plumes of ionized gas that flow outward into space. The sun's corona has a temperature of more than 1,000,000 degrees Kelvin, which is much higher than the solar disk temperature of around 6,000 K.
The solar corona extends up to several thousands of kilometers above the solar disk that we see. And this solar corona, its temperature is 10⁻⁶ degree Kelvin, that means 1,000,000 degrees Kelvin, while the solar disk, which is also called the photosphere, its temperature is only 6,000 degree Kelvin. So it is a big puzzle as to how come the corona, which lies above the solar disk, extended to up to few thousand kilometers, is so much more hotter than the photosphere, which is only 6,000 degree Kelvin.
How the corona gets heated to such high temperatures is still an unanswered question in solar physics, one that Aditya L1 mission may find an answer to. To study the sun, the Aditya L1 mission will carry 6 payload, including visible emission line coronagraph to study the diagnostic parameters of solar corona, solar ultraviolet imaging telescope to image solar photosphere and chromosphere in near ultraviolet and measure solar irradiance variations, Aditya solar wind particle experiment to study the variation of solar wind properties as well as its distribution and spectral characteristics, plasma analyzer package for Aditya so as to understand the composition of solar wind and its energy distribution.
The coronagraph is a very, very interesting instrument. I mean, if any of you have seen total solar eclipse, when the moon completely covers the disk of sun, then the corona is visible. Okay? Otherwise, corona is not visible. This coronagraph will create artificial eclipse of the sun so that you can see the corona. That is a coronagraph. So it will carry a coronagraph which will provide us how on real-time basis the corona structures are changing. Okay? Third, the X-ray cameras and ultraviolet rays telescopes in this mission will be able to study the depth of sun, the chromosphere and photosphere. What's happening in chromosphere and photosphere, it will be able to study.
It will also carry a magnetometer to measure the magnitude and nature of the interplanetary magnetic field. The different payloads are being taken care of by multiple institutions, and hence the project provides an opportunity to solar scientists from various institutes to participate in space-based instrumentation and observations. With inputs from Leena Sharma, Bureau Report, RSTV. 2019 has been a busy year for ISRO. It included the launch of a wide array of space probes, missions and satellites. One of the major ones that kept the nation's eyes focused on space was the Chandrayaan-2 mission. Let us see what were the other significant endeavors of ISRO. Year 2019 was eventful for ISRO with the ambitious Chandrayaan-2 and many other launches. Let's have a look at the major ISRO missions in the year. On January 24th, India successfully launched Microsat-R, which is an imaging meant for military purposes, along with student-built nano-satellite Kalamsat from PSLV C-44 in Sriharikota. This is the first mission from the ISRO in 2019. PSLV C-44 was unique in itself, as it was for the first time that ISRO used the last stage of the rocket as a platform to perform experiments in space. India's telecommunication satellite GSAT-31 was successfully launched on February 6, 2019 from Kourou Launch Base, French Guiana by Ariane 5 VA247. GSAT-31 provides continuity to operational services on some of the in-orbit satellites. It also provides Indian mainland and island coverage. EMISAT was successfully placed in its intended sun-synchronous polar orbit by PSLV C-45 on April 1, 2019. The satellite is intended for electromagnetic spectrum measurement. On 22nd May, India launched RESAT-2B-AA radar imaging Earth observation satellite developed by ISRO. Its launch vehicle was PSLV C-46. Its images will be used in the fields of agriculture, forestry, disaster management. India's geosynchronous satellite launch vehicle GSLV Mark III successfully launched Chandrayaan-2 on 22nd July 2019. Chandrayaan-2 was a highly complex mission, which represents a significant technological leap compared to the previous missions of ISRO with the goal of exploring South Pole of the Moon. It was a successful mission, despite lander Vikram losing contact with ISRO's ground stations back on Earth, as the orbiter continues to relay information to ISRO. On 27th November, ISRO launched Advanced Earth Imaging and Mapping Satellite Cartosat-3 along with 13 other commercial nanosatellites. Cartosat-3 was launched aboard the PSLV C-47 launch vehicle. It will address the increased user demand for large-scale urban planning, rural resource and infrastructure development, along with coastal land use and land cover.
Chandrayaan-1. Then of course we followed it by Chandrayaan-2, though there was partial setback on certain aspects of those mission. We reached Mars. There is a plan to send one more mission to Mars. There is a Chandrayaan-3 coming up. People are talking about it already. The Aditya L1 mission is one such mission. The AstroSat, which is a space laboratory that we had launched, multi-wavelength space laboratory we have launched, is performing very well. It's giving very interesting results which no other space satellite have been able to do until now. One of the other, what I would say, that exciting mission of ISRO is a mission to Venus called Shukrayaan. I mean, at least popularly it's called as Shukrayaan. What will be the final name, we don't know.
On December 11th, ISRO launched its Earth observation satellite RESAT-2BR1 from Sriharikota. Along with RESAT-2BR1, PSLV C-48 also carried 9 customer satellites, including 1 each from Israel, Italy and Japan, and 6 from USA. Polar Satellite Launch Vehicle achieved a landmark with its 50th mission. The satellite will help in agriculture, mining, forestry and coastal management, soil monitoring, disaster management support, and round-the-clock border surveillance. Bureau Report, Rajya Sabha TV.
With this, we'll halt in for a quick break, but we'll be back soon. Stay tuned with us. Welcome back. You're still with us on In Depth. The sun provides energy that allows life to exist on our planet. But we should never forget that its energy comes from incredibly supercharged environment that includes solar flares, coronal mass ejections of charged particles, and the solar wind. Scientists therefore need to understand its behavior and how its radiation affects us. That has been the underlying theme of mankind's efforts to study the sun. Here's a look at some of the prominent missions to the sun.
Solar missions have been sent since 1960. These have all had different objectives. Some significant missions that were sent after the turn of the millennium include the Genesis. Sent in 2001 by NASA, it became the first spacecraft to capture a sample of the solar wind. Solar wind is a constant stream of particles that emanate from the sun. After a 3-year mission, Genesis returned to Earth. Unfortunately, it had a hard landing when its parachute didn't deploy.
But the samples that did survive allowed researchers to conclude that the Earth was possibly formed from different solar nebula materials than those that created the Sun. In June 2010, France launched the Sun monitoring satellite Picard. The 143 kilo Picard is based on a microsatellite platform. It was launched by a Russian rocket. The satellite carried 3 instruments: the 11-centimeter diameter SORISM telescope and 2 radiometers to measure solar irradiance. Picard was on a 2-year mission to unravel the mysteries of the Sun. In 2018, NASA launched the Parker Solar Probe to dip directly into our star's outer atmosphere, or the corona. The probe was designed to help answer fundamental questions about the solar wind that streams out from the Sun, flinging energetic particles across the solar system. It was the first spacecraft to be named after a living person, astrophysicist Eugene Parker, 91. Who first described solar wind in 1958.
NASA and Japan have sent something called Stereo A and Stereo B, 2 spacecraft which go around the Sun to study the Sun very closely. The other mission that has been sent to Sun is the Parker Solar Probe, which actually has gone very, very, very close to Sun. In fact, it's going to make orbits in such a way that ultimately it will go and crash on the Sun. That's how it will end up.
NASA has sent several missions to study Sun, like SOHO. SOHO is one mission which has been studying the heliosphere, Sun's atmosphere for some time. But this is going to be the first mission from ISRO to study Sun.
The Parker Solar Probe will explore the corona, a region of the Sun only seen from Earth when the Moon blocks out the Sun's bright face during total solar eclipses. Scientists view the corona as the answer to many outstanding questions about the Sun's activity and processes. In December 2019, NASA announced the first results from the Parker probe. The spacecraft had provided the closest view of the corona so far. In February 2020, NASA will launch the Solar Orbiter. This is a joint NASA-European Space Agency mission that will address central questions concerning the Sun. The Solar Orbiter will address some of the big questions in solar system science. It will help us understand how our star creates and controls the giant bubble of plasma that surrounds the whole solar system and influences planets within it. With inputs from Leena. Bureau Report, Rajya Sabha TV.
And that's it from us today in depth. We'll be back same time tomorrow with a focus on another key subject. You can also watch our program online on YouTube. Suggestions and feedback about the program are also welcome. Thank you so much for joining us.